Hi David, I'm going to be going over pages 2 and 3. The first problem on that page, which is number 3, this one is looking at the question before this. So we're trying to solve for from point A to point E. If we look at the graphs before this, at point A we had all gravitational energy, and at point E we had all kinetic energy. From this we infer that EG equals EK. Now we just can plug in the formulas. EG is mgh equals, and then EK is 1/2 mv squared. From here we're just going to solve. So I first divide by m to get rid of it. So GH equals 1/2 v squared divided by, multiply by 2, to get rid of that 1/2. So v squared. Then we just take the square root to get v by itself. So v equals the square root of 2gh. That is our final answer. If we move on to the next one, it's the one talking about this diagram. Let's see. Okay, so first of all, this point is EG, and this point would be EK. Because here is before we drop, like when we barely drop the ball, and this is when it's entering flight, and then so be 1/2 gt squared. So first we're gonna set up our equations. So I'll mark this h1 by the way. So h1 would equal 1/2 gt squared, and d would equal b not t. So we're just gonna solve for t using this one. So b naught equals d over t, and for this one we're gonna solve for the h. So sorry, not the h. We're gonna solve for t. Sorry. So we're gonna multiply both sides by 2 first, just to get rid of that 1/2. Divide by g. 2h1 over g equals t squared. And then we are going to square root it to get t by itself. So t equals square root of 2h1 over g. 2h1 over g. Okay, now we're going to remember that we're doing from EG to EK, from point A, from this point to that point to solve for H2. So we can do this. Now we are going to keep up. 1/2 mv squared. Okay, so we're going to divide by this m to get rid of them. We have GH2 equals 1/2 v squared multiplied by 2. 2gh2 equals v squared. Now we are going to, we're trying to get h2 by itself, so we're going to divide by 2g. So h2 equals v squared over 2g. Remember that we already solved for v over here, so we're just going to plug it in. 2h1 over g squared over 2g. So here we're just going to carry out this square root. The square root. So then we're going to get, I'm missing something. Okay, so then the reason I got confused is because I did solve over here correctly, but I forgot to plug in correctly, so I forgot my d. So then if I carry that square root, I'll get h2 d squared over 2h1 over g, and then the 2g. Just be put that way. Now we can see that a g would cross out, and that so from here what we're going to do is just multiply these two. And we have gotten our answer for H2. pause it and go on to the next question and just erase this. The next question tells us that if a bullet is dropped and a bullet is shot, like how they would fall, which one would fall first. The answer is that they would fall at the same time because the force of gravity is just pulling down at the same rate. The next question on our paper is it the one of the triangle?
Mm-hmm.
Okay. So for that one, I like to start with my diagram to understand the situation. We're going to solve for t here. And then we're going to do the naught t squared d squared plus d squared. Okay, so from here, I'm just gonna carry out the square to make it easier for myself. Two d squared, this simplifies too. And then from here, I'm gonna divide by t squared, because we're solving for that b. And then we already solved for t squared previously, so we're just gonna plug that in. And then from here, in order to multiply, I had to flip them. And then we can see that the 2's were crossed out, and so would 1d. So we give us v naught squared equals dg. So from here, I'm just going to take the square root, and then we'll leave v by itself now. So v naught equals the square root of dg. Okay. So the next question is on is the next question the graphs?
Yep.
Okay.
But we'll pause it because
I'm
you
gonna
could
draw
draw
them
them
out.
out first. There's no more room.
Okay, so I'm gonna draw the flight and landings for the thing. Constant. So then we have that there. This here. Do that there. And our force diagram is just gonna be all gravitational pulling, all gravitational force on the balloon. And then for landing, we're gonna have a little, it'd be like this. Hopefully I draw it right. This would be like that. No, that would be, I'm confusing my x and my y's. And this would be that. This would be because it's a little, okay. And our force diagram looks a little different because we have two forces at play instead of one. We're gonna have the force of the ground on the balloon, and we're gonna have over here the force of gravity on the balloon. Okay.
And that's it.